Okay, welcome to our last session, uh, time series modeling in R. So let me share my screen first. So can you see the screen now?
Yes, Shada, that's visible.
Yes, sir. Okay. So this is time series and forecast analysis using R language. So first of all, any idea about time series?
Basically, it's the data that is available with respect to time. So you can
Correct.
say in one dimension you have time, in the other dimension you have the data.
Correct. So the time series data is with respect to any particular time interval, let's say monthly or quarterly or annual, like this. So you can convert any data, even if you have sales data or cost data or even stock market data. Like in the last session, we have done financial market analysis. So you can convert that data into a time series data. So have you done your practice of financial market analysis?
Shada, sorry, I didn't do anything because we are in budget process.
Mhm.
So I'm working actually whole day on office work.
So you have to go through the last session also. That was very important. That how to import data from any website. Let's say we have done in the last session from Yahoo Finance website, or you can go to the World Bank data site also. I will share with you the link, and or you can just Google the World Bank data, and in that you can find a lot of data sets, economic data, financial data, etc. So you can get any data and just try to import it in a different way. First way is to save it as a CSV file and then import it by using the read.csv command. That is very important. So in that way, you import the data. Once you import the data, you can convert the data into a data frame, and then you can convert it into a time series, which we will see today. So, and then you can analyze data by using a number of statistical functions and using plots also. So, time series analysis is being used in financial services sector, banking, and manufacturing, financial market analysis. In financial market analysis, we have stock market data, like in the previous session, we have seen a number of indexes like Dow Jones Index, S&P 500 Index, like this. So we can predict the interest rates and other variables and check the volatility in the stock market data by using different measures such as standard deviation and variance and mean also. So how to transfer the data or convert the data into a time series data, we'll see by using the function TS, and in parentheses data, whatever data we define, or either a vector or whatever, or data frame. Then we just give the start date, then comma end date, and then frequency. Either 12 means monthly, or 4 means quarterly, and 1 means annual. So in that way, this is the syntax how we transfer a data frame into a time series data in R. So first of all, we'll just cover the basic concepts in time series, that what are the trends, fluctuations, and all these residuals also. And I will share with you these lesson notes also, so that after the class you can go through these in detail, because this time series analysis, there are very basic terms and concepts are there. You should first understand these terms, then you can apply in R. So first of all, time series data can be analyzed for trends, seasonal fluctuations, and residuals. And you can see that trend analysis involves linear regression model, which we have done in the statistical analysis. But let me tell you about the basic concepts of time series. What are the terms involved in time series? So let's say if you have any sales data, either from the website or from any particular your company's manufacturing or sales data. So you can just import the data in R, and then you have to apply some time series modeling concepts on that data, to analyze the data, to perform the various statistical functions on that data, and to perform data visualization by plotting. So first of all, you should know the time series modeling. What is time series modeling? It allows us to replicate every element of the process by decomposing or deconstructing the mathematical process, the mathematical regression equation process, into a combination of signals. That is either the year over year growth. You are interested to find out the year over year growth in the sales, or month to month, like that. So you have to see if you have, let's say, sales data over the last 2 years, and you want to find out, you want to perform the time series analysis on that data. So you should see that what are the trends or patterns in the data. Let's say if you have data for the last year, for 2022, starting from January to December, 12-month data you have. So in Excel also you can perform various forecasting functions are there. Let's say there is a forecast option also, and in Excel one formula forecast.ts also there. So I have one PPT for Excel. I will share with you that also. So you should apply that first, because we are doing mostly our work on Excel. So you should be familiar with the Excel forecast function. We can draw a linear trend line on Excel, in Excel. If you have two variables, let's say sales and the other any cost, any marketing or advertisement cost. So you should know that one is a independent variable and the other is dependent variable. Let's say the sales revenue depends on the marketing cost, so, or advertisement cost. So if the cost is increasing, then you will have increased revenue in revenue. So in that way, you can first, the first option you should use in either Excel or any package is to draw a scatter chart. This is the best way. So once you draw the x-axis independent variable and y-axis on dependent variable on the y-axis, you just go to Excel recommended chart options and just click on the scatter plot. So it will draw a plot with x and y values, and the dots will be shown as the trend. So you will see by plotting a scatter chart of two variables, the relationship between the two variables. What is the linear relationship between the two variables? Either the dots are near to each other. So there is an option in Excel. If you have just go to the scatter chart and draw these two x and y, you will see the in the plot. If you right click at the down area, there's a plus. If you right click on that, you can do the linear trend analysis also. You can draw a line, linear line, and a lot of functions are there. You just see Excel has a lot of functions. So in that way, you can compare that what we can do in R. So now come to R. We can perform the patterns, trends, seasonality. Seasonality is that, let's say you have sales data for the last year. You can see in some months there is a little difference in the sales figures, let's say January to March. So, but if the product of the company is based on the seasons, so let's say in the summer period, the sales might go down. So you can see in between June to August or May to July, the sales might decline. So it's due to the seasonal effect. This is what we call the seasonal effect. And you can see the trend in data also. Okay, sometimes due to some events, the sale might increase. So that is called what are the trends. So in that way, if you draw a plot, you can find out the patterns and trends in the data, and you can find out the seasonality. And then the last thing is the noise or shock. What is the noise or shock is in the time series data. If due to, let's say, in any period, the company is manufacturing or producing the ice creams or anything like that. So in that way, there might be in some period, if you increase the advertisement, so it's like a shock, or any other external, due to external factor, there might be increase or decrease in the sales, huge difference in the increase or decrease in sales. So that is called the shock or the noise in the time series data. So that's what we are looking at. The time series can be analyzed for trends and patterns, seasonal fluctuations due to the seasonal nature of the product, and the residuals and noise. So this you can compare with the linear regression model also, in which we have two variable independent and variable dependent variables, and the data should be adjusted for seasonal fluctuations to so that it shall not significantly influence the regression results. First, we have to remove the seasonality, and the residual is what is left over after the trend and seasonality has been diminished or considered. So in this way, this case consists of a cycle and an error. So that is called the error or white noise or shock in the time series data. So you can go through these and you will see the how to do the decomposition analysis or there is a additive time series and multiplicative also. So just go through this how to perform the decomposition method to fit a linear regression of data and to find out the trends and seasonality. And then we will see there are two types of time series data. One is stationary and the other is non-stationary. Do you have any idea of stationary and non-stationary time series? Hello.
No, sir, I don't have idea.
Stationary time series is that in which the
No.
statistical measures like mean and variance are constant. Let's see in this figure. You can see in the down there are one plots. One is the stationary down, and the at the top is the non-stationary. In the stationary plot, this is the stationary time series because if you see at the x-axis is the time interval and at the y-axis is the activity level. So if you see there is not much trend or fluctuation in the start. So from going from one period to the next until the 60, there is a constant, any mean and standard deviation remains constant. And then there is a slight fluctuation. And then after 100 also, it remains constant. So a stationary time series is that in which the statistical properties, let's say mean and standard deviation, remains constant over a period of time. While non-stationary time series is that in which the statistical properties like mean and variances change over time. If you see the upper graph, there is a huge difference. Sometimes it's going sales activity or anything going too much up, then going down. There is a big fluctuation in the data. That is, you can say that the time series is a non-stationary time series. So then you can go through the properties of stationary time series, in which the mean should not be a function of time, rather it should be a constant. In the stationary time series, mean and variance should be constant. Yani the variation should be constant. If there is a variation from one month to the other month in the data, if let's say 100 is a variation, then it will be for the next lag also, going from 100 units to 200 units. If and from one lag time period to the next, the variance should be the same, constant variance. But in the non-station time series, the variance from one lag period to the other will change. The variance will not be constant. So in the stationary time series, the variance of the series should be constant and should not be a function of time. And this property is known as homoscedasticity. And when in the non-stationary time series, if the variance is not constant, that is called heteroscedasticity. So these are the time series terms. Don't get intimidated of these terms. So why is stationary time series? The purpose is that when we are predicting a model, a time series model, then we should make the time series or convert the time series into stationary. Because if there is a non-stationarity in the time series data and there are trends and seasonality elements, so first we have to remove this seasonality elements and convert it into a stationary time series. Then only that we can apply the models on that data. So the best indication of this when data has past instances is stationary is that when you can see that when you plot the data, I mean scatter or plot or any plot, then you can see the trend of the data. So if the data is showing in the plot that it is not stationary, then the first thing is you have to make it stationary and then apply the models on that. Like you can apply the time series models, linear regression models, and there are some of the ways to make the series stationary by detrending or differencing. So we'll see. So time series are stationary if they do not have any trend or seasonal effect. It means if there is no trend, there is no seasonality effect, so the time series is stationary. There must not be much variation in the data. So you can see this whether the time series is stationary or not by plotting the time series. Then we will see the other concepts also. Any question till now?
No, Shazad.
No, sir, it's
Okay.
clear right now.
So move on to the next. What are the statistical conditions or statistical measures we can apply? Any idea?
Intercept and slope maybe used.
कौन से statistical measures हम apply कर सकते हैं?
Intercept and slope function apply करते हैं.
Which options?
Intercept and slope बोलते हैं.
No, मेरा मतलब है कि statistical moments कौन से होते हैं, like mean and standard deviation. These are the statistical moments. Okay. Like the statistical descriptive statistic measures or moments. These are called moments also, like mean and standard deviation. Mean is the first degree moment, and then second is the standard deviation. Then skewness and kurtosis. Skewness is the third degree moment, and kurtosis is the fourth degree moment. So these are also called moments. So we can apply statistical moments such as mean and standard deviation, and then we can see whether the data is stationary and non-stationary by plotting it. On the scatter chart, we can see that it's stationary or not. We can see the trends in the mean and standard deviation. And what is the seasonality? Is the trends and patterns. If the data is showing different patterns or seasonal elements, so it means there is a seasonality effect. Then what is the correlation? Correlation is the relationship between the data. That if there is a positive correlation, means if one variable is increasing, then other is also increasing. If negative correlation means if one variable is increasing, the other is decreasing. Then we can find out the autocorrelation factor by plotting by making a graph. What is the autocorrelation? It's a degree to which time series values in a period t are related to time series values in the next period, let's say t+1 or t+2. So we can see from one period to the other period what is the degree of relation by plotting, making a autocorrelation factor ACF graph. Then we can perform the decomposition of data and decompose or deconstruct it into different component parts. We build a model to simulate the process. And what are the filters applied to the time series data in this filtering process is detrending, which we have just discussed, that we have to make the eliminate the seasonality effect or trend effect in the data by detrending. Then autocorrelation, we have to plot the data, autocorrelation plot. Then we have to find out the outliers. Then we can apply the smoothing, that is moving average or exponential smoothing, which we can perform smoothing in Excel also. Then correlation, there is a formula also of correlation, which we can apply, that covariance. If there are two variables xy, we have to find out the covariance of xy and divide with the sigma x into sigma y, that is the standard deviation of x multiplied standard deviation of y. So these are some of the concepts which is related to the time series, which I have discussed. Then after this, we will move on to stationary and non-stationary we have done. So we can do some coding in the R. So time series forecasting is, I've just discussed, it's already in production, manufacturing, stock market data, and it's used by government also, find out the populations and all this over that particular time period. And time series components, we have discussed in the data, there are time series patterns over time, and these patterns are classified into 4 components. First is the trend. What is the trend is a gradual change in the time series data, like if from going from 1 month to the other. Let's say in June, July, there is a significant change in the data. It means it's this graduation is called the trend. The trend pattern depicts the long-term growth or decline. So we can say there is a trend and effect in the time series data. Then level of the data, we can see the baseline
Guys,
value. Validity.
your screen is stuck.
Sorry.
Sir, I feel that your screen is stuck. It's not moving.
Okay, so you can see my R screen, R Studio or no?
No, you are
Okay, I will
especially
I will
non-stick.
reshare. I will
So,
reshare it. Yeah, I'll reshare it. Yeah, my PPT has stuck, so I will try to reshare the R screen now. Share screen and R. Now you can see my screen.
yes,
Yes.
sir, I can see it now.
It's R Studio.
It's our studio.
Okay, so last I was discussing the time series components after trend and seasonality, noise, which I have discussed. These are the random shocks. So it represents irregular variations due to the random element, and these fluctuations are unseen, unpredictable, and cannot be explained by the model. So these are called random shocks or errors. So in that we have some time series modeling techniques like ARMA model, which we will discuss at the end. So now I'm going to do some, you please open your R Studio. So let me apply some of the coding. Let's say you can, I can open file or you can open a new script. Or we can perform a basic exercise. Let's say this one. So first you have to install a package that is XTS. By using the command install.packages and in parentheses inverted commas XTS. You have installed? Hello, you have installed the package?
Yes, sir, I have installed it.
So then once the package is installed, then you have to load this in
Just
each
give us a
session.
minute to install.
Yeah, sure. It will take some time. So once the package is installed, you don't need to install it again in the next session. You just need to load it again in the next session by using the command library and in parentheses XTS. Every time in each session, you have to load it by giving the library. Okay, it is loaded. Is it loaded?
Yes, sir, no, it's loaded.
Okay. So first step is create the sales data. So we can make a data frame by giving the variable sales and then assignment operator. This is the code data.frame to make a data frame of the sales data. And in parenthesis, date is equal to, we can give any particular date, like I have given 5 dates, but in the as a vector, data frame date is equal to C, and in parenthesis inverted commas, 31st December 2018, then 31st December 2019, then 20, 21, and 22. So 5 dates I have given. Either 3, 4, 5, whatever you want. Comma, values I have given as VAL short form, or you can give sales value is equal to another vector C. Here I have given the sales values. You can give 1000, any values, 100, 200, 300, 400, 500. These are our sales for this particular period, these periods. Yani 2018, 19, 20, 21, and 22. So can you type this? Hello.
Yes, sir. Doing
Yeah,
it.
Sharad, just installing because I'm getting an error in installing the XTS.
Okay, no problem. Let it make the data frame. And if it is taking time, no, you can make the data frame. Can you type and make the data frame? If it is installing.
My is free.
So anyone who has installed, just type make the data frame of sales data, sales assignment operator data dot frame. By giving the data dot frame command, you can
What
make
does
the
this command does? I've done it, but want to make it clear what it has done. Created a data
okay,
frame
just
of dates.
mm, because if you do it, then only you will understand. So can you make the data frame sales assignment operator data dot frame,
Yes, sir, I've done it.
and in parentheses date is equal to C. You have to give here 4 5 dates, but in inverted commas, like in that format, 2018 first year, YYMMDD, in that way, in inverted commas, with commas. And then value is equal to C. 5 sales values you have to give. This is one of the way that we can make a data frame, or either we can do in another way, which you will do in your practice, to get a file of your sales data and import it in the R by using a read.csv command, and then work on that. So this is just I'm trying to teach you that how to make a data frame out of the sales data. Okay. So once we double click on this, it has created a sales data. So if I check the sales data is correct or not, let me check the sales and control enter. So it has given me the dates, like if you can see in the console area down, 31st, starting from 31st December 2018, then 19, 20, 21, and then 22. And values are there from 100, 200, 300, 400, 500, which we have defined. Okay, this is the first step. Then the second step is to convert it into time series. But before this, we have to tell R that we want these sales data dollar date an assignment operator as dot date sales dollar data, that to consider this the first column date as a date column. So we have to give this command sales dollar date assignment operator as dot date sales dollar date. So in that way, once we apply this, so it will consider the first column as date. Now convert this into this data frame into time series by using the command sales underscore ts or sales.ts, whatever variable you can define. Assignment operator xts, in parenthesis sales dollar value Sales is your data frame which you have created up. Dollar value is your second column, comma sales dollar date. So it will just create a time series data or convert the data frame into time series data by assigning two columns. One is the date column of your sales data and the other is the value column. So our sales underscore TS has created. So let me check the sales underscore TS. Control enter. So if you can see down, it has shown the dates and then the values. And if we check it is .xts sales underscore TS, that is time series data. So control enter, it's showing true. Okay. And we can check the class of this sales underscore TS also. Sales underscore TS. That what is the class of this? It's showing XTS zoo. That
What is
is
this
the
wall?
package.
Sales dollar wall.
And val is the value. You can put type full value, VALUE or simply VAL.
Because it has
Okay,
given me an error.
it's for value. So for values we have
No,
defined val, VAL.
but where we have defined it before.
Yeah, we have defined it for values.
Yeah.
Values VAL is equal to C, and in we have assigned a vector. For vector, we have to use this C parenthesis. In this, we can assign any values. If we have sale values like 1000, 2000, then we can give 1000. So it's just a basic way to make data in your data frame as a data frame by giving dates and assigning your sales values. Then convert it into the time series data by giving the XTS command sales TS XTS sales dollar value comma sales dot date. And then you can check its class. It's showing XTS zoo, that is the time series data XTS. Done.
Error in XTS sales well sales date. I don't know why it's showing.
Here I have done sales underscore TS is a variable. Means first my variable was sales. Now I am converting this sales into time series data. For time series data, we are using this command XTS sales underscore TS assignment operator XTS, and then in parentheses we have to define the two variables. First column is the one column is the value column and the other is the date column. So sales, first you have to write the data name. The data name is sales, dollar sign for the column. First is one is the value column val, comma sales is the data set name, dollar the second column is date. So in that way it has created the time series
ये
data
जो well है
showing the
ये
dates
ऑटो पे नहीं आ रहा but date का लिखते हैं तो date का option it's giving a date option but well option it's not giving. I don't know and it's displaying an error.
just in your practice you have to follow this command. I will share with you all this so you can see where is the error, because if you define the variables properly there will not be any error. Sales first data is the sales, and here
Yeah, I
val
think
is
so.
then sales dollar date as dot date sales dollar date, then convert it into time series sales underscore TS assignment operator XTS sales dollar val comma sales dollar date. Okay. So I will use another basic file also for the time series data, which will show you the R datasets. Anyone has done this or no? Anyone has done this? Anyone has done this or no?
Sir,
No,
still
sir.
giving it.
क्या problem आ रहा है?
Sir, in the XPS sales dollar value, sales data.
अच्छा, एक और हम लोग practice करते हैं. One more. Let's say we have two types of stock, so we can assign the vectors in that. These are just for just teach you some of the options, that because there are hundreds of ways of doing the time series data in R. So let's say open a new script. Then we will define by using the simply TS function, because here I was using the package XTS. Let's say we are just defining a vector of sales or stock, anything. So you can apply this to your sales data also. So let's say we have stocks, stock data, like there are two stocks. So stock one is C, just assign a vector C and then in parentheses 10, 20, 30, 40, 50 like this. Are you doing? Can you assign the first vector with numbers from 10 to 90?
Just
Hello?
doing.
Okay. Stock one, assignment operator C in parentheses 10 to 60 or 90, 10 comma like this. Then stock two, then C in parentheses any values from, let's say, 100 to 900 like this. Okay.
Done.
Stock one and two done.
D.
Now we have to combine these stocks. So do you remember in the first session, we just learned two techniques of combining by C bind, R bind, or matrix function. You remember these functions or no?
Yeah, C bind, R bind, I remember.
Remember, no? One matrix function was also there. So you can just combine these stocks by giving the variable. I have given the variable comp stock. Comp means combined short form. Comp stock, parent assignment operator, matrix. This is the matrix function. Matrix, parenthesis C, then again parenthesis stock one comma stock two. Okay. Then n row is equal to 7 means I want to convert it into a matrix with number of rows 7. Okay. Matrix C stock one comma
So,
stock two comma n row is equal to 7.
Shahid,
Then
it means,
Data was
Shahid, it
7
means we are
rows, 7 rows.
limiting the
Hmm.
rows. So 80 and 90 will not come into the matrix.
Yeah, we are limiting the rows. We are assigning the rows that the number of rows should be 7.
Okay, okay.
So just do it. Then only you have to do a lot of things, then only you will learn and you will find the differences. That in how many ways we can use these functions and commands. Practice is the only, there is no other. Okay. Then if you have done this, let's say I'll do this again, this stock one, control enter. Now my stock one variable has defined in the environment at the right hand, upper right hand side, you can see stock there. Stock two, control enter, stock two is there. Okay. Then I'm combining these two stocks by using the matrix. I'm just telling you another option, that instead of matrix, you can use the R bind and C bind command also. They are also making the R bind is making the matrix by the row wise and C bind by column wise. So just apply these also in your practice. Okay. Then com stock to create a variable combined stock. When we see the combined stock, it will show us down on the value. Now convert this into time series data. How to convert it? we have to give another variable name. Let's say comstock dot ts, because comstock we have already defined by combining these two stocks. So in order to create a time series, we have to give another variable, comstock.ts, assignment operator, by using the ts function, ts parenthesis, the combined variable comstock, comma. Here you should see carefully that after giving the variable comstock, we have to give the start date and end date. So it's equal to start equal to c 2012 comma 1, means it will start from the year 2012 first period, comma frequency is equal to 4. If we give frequency is equal to 12, it means monthly data. Frequency is equal to 4, it means quarterly data. Frequency is equal to 1 means annual data. So now control enter. So this comstock ts has defined.
Shazad, is it possible to go up to the week level?
Sorry, repeat again.
Shazad, is it possible for us to give frequency? We have to go on with more detailed level.
Yeah, we can give frequency 1 for annual, 4 for quarterly, and 12 for
Yeah.
monthly data. There are 3 options only, 1, 4, and 12
Okay,
in
we
this
cannot go
way.
below this.
No.
And
So comstock.ts, control enter. So it has given you down, you can see in the console, year, then columns, quarter 1, 2, 3, 4. Can you see? Hello? You can see down in the console?
Yes.
yes,
So now we have to plot it. How we can plot it? How we can plot it? The basic command for plotting is plot command. Otherwise, there are a lot of other options, chart series and like this. But I'm using the plot command. Plot, parenthesis, the combined time series variable we have given, comstock.ts, comma, main is equal to multiple stock prices. This is a main heading. So once I click control enter, a chart is there at the right and lower side. Can you see the chart?
Yes.
Multiple stock
yes,
prices. Okay.
But it is not red. You have given column a red color. You have done a
Multiple
second
stock
one.
prices. Hmm.
Okay. No. What about this one? Plot
So
stock
we can
one
give
stock.
here x equal to series coming. So now if we want to generate the random number, we have to first set the seed. I told you in the statistical functions class, statistical analysis, that when we are creating the random numbers, if you want to fix it, that every time when we generate it, it will generate the same numbers, we have to use set.seed command. And then in parentheses, we can give some numbers, 1000, 1 lakh, anything like that. So I am setting the seed, set.seed, and then any number, 1000, 2000, 10,000, you can give in this. Then control enter. Now I am creating a variable data and round data.frame. Year is equal to 2001 to 2025. For these years, I am creating the 3 time series. TS1 is the first time series, TS2 is the second time series, and TS3 is the third time series. So first TS1, I'm giving 1 to 25 plus R norm 25. TS2 is 32.6 plus run if 25.010 and all this. So when I will run, it has created 3 variables, TS1, TS2, and TS3, the data in the then I will check the head data. It will show me the size of the data, that is year, columns TS1, TS2, TS3. make it or convert it in time series data combine.ts and parentheses that comma same way like I have done above, start is equal to C 2012, 1 frequency is equal to. So it will convert this data into time. It has created the combine.ts time series. Check this. Now my data is there down with the dates, any months and year. Then TS3. You can plot it by giving the data main is equal to multiple stock prices, color is equal to red, so or color is equal to so this has plot multiple stock prices. So you can see that if you can see in the down right down area, the plots are there. So now you can compare this R visualization or plotting options with Excel, because in Excel we can plot in different ways, make different types of, but we cannot make plots in such a granular level in Excel, because there is such options are there to make for each time series wise plots and different plots inside granular level. So okay, you can see the plots, multiple stock prices plot at the right hand side.
Yes, sure.
You can see.
Yes.
So this is the difference, that when we compare Excel and R, we can see that in Excel we don't have such options at the such granular level. We cannot make the graph, but here in R we have a lot options are there. The last class also we have seen, or one more I do another step in which you can see that how to do the plots or any data. Let's say we have is EU stock data. So if you see EU stock data, we have, and then we can see TS dot plot Euro stock markets. One is the Euro stock market data. If you type EURO, it will give you the Euro stock market, Euro, and Euro stock market also. Euro dist and Euro stock market. Okay. So these type of data sets you can see, and let's say I'm going to plot it as TS dot plot Euro stock markets column 1 to 4. X lab is for the headings of X axis. X lab is equal to year, and Y lab is used for heading of Y axis. Y lab is equal to index value. Main is equal to major EU stocks. That is the main headings. So in that way, if I plot it, so it has plotted the major EU stocks, and on the X axis are the years, and the Y axis is the market value. Can you see the plot?
Yes,
Hello.
Shazad. Yes,
Okay.
Shazad, how you have changed the series color, because all series are different colors?
Because I have given here in code, you can see call is equal to 1 to 4. Okay. So if you change here, it will show you. If we change call 1 to 5, see what it will do. So you can apply various commands. We can even give call is equal to inverted commas, the particular color, so it would give that color, or we can give the 1:4, 1:2 like this, so it will change the colors. So just apply it in your practice, you will see how it will working. Okay. Because call is equal to 1 to 4 we are giving. It is defining the colors. Then we have another TS1 data. One simple time series you can make. Can you open a new script? My series and you have to assign a vector. Can you see this?
Yeah, Shazad, we can see making.
So you can assign this variable my series assignment operator C, and in this you can give some numbers. Let's say I've given C 18, 33, 41, 7, and so on till 26. So these are the 12 numbers. One, yes, 12 numbers you have to assign. Any random numbers, just assign 10. C 18, 33, 40, any numbers till any 12 numbers you have to assign, because I am giving the monthly frequency 12. Okay. As a variable my series. Done. Then we will convert this variable my series into a time series data. So T sales or sales.ts, anything you can assign as a variable. Assignment operator, the function TS for time series data, parenthesis, data is equal to my series, comma, start is equal to 2003, comma, frequency is equal to 12. So what it will do, first we have to assign the variable my series. So the variable is assigned as my series, then convert it into a time series data. So T sales TS, parenthesis, data is equal to my series, comma, start is equal to 2003, frequency is equal to 12. So it has created a time series data. Now I want to see the T sales, enter. So you can see it and down in the console that it has created monthly data for year 2003 from January to December, and it has assigned the numbers which I have given in the vector my series. Then I can plot this by giving the generic command plot of this variable T sales. This time series data can be plotted. So you can see here in the right lower area, the plot is there for the time I have defined the periods and T sales. And then another way of plotting this T sales, you can give type is equal to in inverted commas O, comma PCH is equal to 19. It's showing the characters, and column is equal to blue. So this is there. You can see the graph. Now I'm giving the color, instead of blue, I'm giving red. Can you see this graph?
Shazad, yes,
Hmm.
Shazad, what is this type means? Type equal to means?
Type equal to O means for dots, we are using this small o. Okay.
Okay, okay. So data points are highlighted by O.
By O. Okay. So this is one of the example. Are you doing the along with me or no?
Yes.
Yeah, that's better. Then we have this TS data. This we have done. This we have done. Multiple regression is there.
Shazad, in case my data doesn't have equal intervals, like I
Hmm.
have the data, but there are every day, every week you have a missing day. So 1 or 2 days
Hmm.
are off days. So
Hmm.
it means frequency I cannot say is one or means day. So how
Hmm.
normally we can avoid such anomalies in the data?
You have to give na.rm. na.rm.
Okay.
Let's
What it
let's say
does?
let's say let me open a new script, and I in my new script I have variable x. I am assigning it as an assignment operator, and anything I can give. Let's say c 1, 2, comma 2, comma 3, comma 4, comma 5. Okay, this I have assigned as a vector x. or I can give x 1 to 1 colon 5, so it will assign the 5 values anyway. Okay.
Yeah.
So if I give
Yeah.
x and control enter, so it has given 1 2 3 4 5. Okay. Or y
Yeah.
assignment operator. Here I am not giving vector. I am just giving 1 or 10 to 20. 10 colon 20. So y is there, y this. So you can see 10, 11, 12 from 10 to 20. So these are the ways to assigning variables. Are you getting?
Yes. But Shazad,
So
my case is that if days are missing in the time series, it's not
hmm,
continuous days. So how to
hmm,
manage that? Because one or two times I did in Power BI
hmm,
time series analysis, and it gave me an error because my time was not continuous.
hmm. In Power BI, there is another method because you have to go to the you have to get the data, and first before loading it in the Power Query editor, you have to find out the anomalies. You have to find out the what are the anomalies. Let's say there are sometimes blank values, sometimes missing numbers. So how to do that? You have any idea in Power BI?
Yeah. Power Query, I can manage that one, but it was like it's a natural character of the data that there is an
Hmm,
off day. So you
hmm,
don't have that day, data is not available.
hmm, hmm,
So in that case, time series was not able to predict because sometimes you are not having, for example, if you go for expense side, sales is happening
hmm,
on daily basis, but expense is not
hmm.
happening on daily basis. It happens
So
on
you can
different
do one
frequency.
thing. In that case, you can do one thing. In the columns, you can give the custom column and then go there and then assign that if this value is not there, give 0. There is an option. You can assign that. If no values for that, give 0.
Yeah, but in that case, in my data, I'm creating zero values, which might impact the trend of the data.
Hmm. And no, if there are no values, so what you have to give? You have to give 0 values or blank
Yeah,
values,
but
because if there is hmm,
let me, maybe I'll try to explain in a different way. मेरा
hmm,
एक्सपेंस हो रहा है मे बी एवरी 10 days के बाद 100
hmm,
रियाल का 200 रियाल का एक्सपेंस होता है, लेकिन कभी वो 10 days के डिफरेंस पे हो रहा है, कभी वो 15-20 days के डिफरेंस पे हो रहा है। तो
ठीक है,
टाइम इंटरवल मेरा एक नहीं रहता, जिसकी वजह से जब मैं टाइम सीरीज अप्लाई करता हूं तो मुझे वो फोकास्ट पे जब जाता हूं, टाइम सीरीज पे तो वो
hmm,
लाइन ग्राफ बना देता है मुझे, लेकिन जब मैं उसको
ठीक है,
फोकास्ट करने को कहता हूं तो वो फोकास्ट में एनॉमली शो करता है कि जी आपका इंटरवल स्टैंडर्डाइज नहीं है, तो फोकास्ट नहीं हो
हम्म,
सकती।
ठीक 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 ठीक। तो वो उसका यही है ना कि आर में तो फिर आपको उसको स्टैंडर्डाइज करना पड़ेगा, स्टेशनैरिटी पे लाना पड़ेगा, और उसके लिए डीकम्पोजिशन वगैरह और वो है, और डी ट्रेंडिंग करनी पड़ेगी। पावर बीआई में देखना पड़ेगा कि हाउ टू डू दैट, बिकॉज पावर बीआई इज अनदर थिंग। सो
हाँ, मुझे सर यही था कि कोई इस तरह का टेक्निक क्या होगी कि इस तरह का डेटा के जहां पे टाइम इंटरवल का डिफरेंस आ रहे हैं,
तो
वो
हाउ टू मेक
एक
फोरकास्ट।
स्टैंडर्ड नहीं रह रहा।
सो लेट मी चेक, but I have one PPT for related to Power BI, in which I have done R integration with Power BI. So, and some analysis also. Let's say, um, in Power BI there is an option that you can ask the question and answer Q&A.
या
किया हुआ आपने?
Q&A, आई एम यूजिंग
और एक
Q&A।
एनालिसिस फीचर भी एक है, एनालाइज फीचर, सॉरी, एनालाइज फीचर इज देयर. So I will share that PPT with you people, so you can see that how to do that. And at the end, our integration with Power BI also I have covered. So steps are there. So if you follow these steps, you can open R script in Power BI also. Step by
ओके,
step is there.
थैंक यू।
Okay, I'll share with you.
थैंक यू
And
शहजाद, थैंक यू।
in R you have to use na.rm for looking at the missing data. Let's say you are taking the mean, but you have to give the mean, and in parentheses you have to give the variable x. It will give you the mean of the x. But if there are missing values, so you have to give mean x, then comma na.rm is equal to true. You can see here na.rm came, in my screen? na.rm is
Yes,
equal
we
to.
can see. Yes, we can
So
see.
it's what is na.rm? It's a logical evaluating to true or false, indicating whether na values should be stripped before the computation process proceeds. So if there are na values in the data and the data is big, so you want R to just get rid of the na data. Don't consider it in it, because if na data is there, so it will give you an error. So in order to remove na data, you have to give command na.rm. Yani remove
So
the
it's just
na
like
value.
if error. It's an if
Yeah,
error
just
for us.
to skip the error, so you give na.rm is equal to true. So it will consider this. Okay. So
Oh,
this is the way. So now I'll see the next area what we have to do now. So now we are going to do the basic data through the dataset, air passengers dataset in R. So open a new R script, and you can close this graph also, and these variables also. So just open a new R script. So we can install the package that is called forecast package. Install dot packages, and in parenthesis, inverted commas, forecast. I think I have already installed the package, so I'm not pressing Control Enter. You have to install this package, and once the package is installed, then next session just load it by giving the library command library, and then in forecast, inverted parenthesis forecast. This is for forecasting time series data. So the package is installed. So you have installed the package library forecast. You have loaded it.
loading.
Okay. So now we can see that uh, we can load a base in base R pack. There is a data set available, that is air passengers. So just load this data set. You can see here the data set by typing air passengers, and then Control Enter. So if you see, you type just air passengers, you can see this data set is there, showing the number of any various years, and then from January till December, this data. Okay. Now we can see the class of this data set by giving the command class and then air passengers. It will show us the class of this data set, that is TS, time series data, because this is the data over a particular time period. So here we can see the start air passengers also. So it's giving the start from 1949, and then end also by giving end, and in parentheses air passengers.
Shazad, in this case,
Yes.
the data has only the year. We cannot see any date. So when we'll be giving the start date and end date, is it okay if
Hmm.
we give only the year?
Yeah, it will accept. It will accept.
Oh,
Or we can give the full date also, or the year also.
so in that case, we'll put 31st December as the date.
Yeah. Or simply give the year. So now find out if there are any missing values. Find out any missing values in this data set. How to find out the missing values? You have to give sum, and then in parenthesis is dot na. There is a command is dot na. It will show you the missing values, NA is a logical content or constant of length 1 which contains a missing value indicator. So NA can be coerced. This is called coercion method, COERCION, coercion. So NA can be coerced to any other vector type except raw. So this is the way is dot NA. And then in parentheses, you have to give air passengers. Okay. So when I can press Control Enter, it is giving me 0. So if there are missing values in the data set, if you check is.na and then data set name, so it will give you the missing values. It will show you where in which period there is a missing value. Okay. You got it? Summary.
Got it.
Summary air passengers. So we can apply the summary function on this data set, air passengers, Control Enter. So you can see in the console down minimum and maximum, and then first quartile, then second quartile, that is the median, then mean and third quartile. This, yani you can calculate the summary statistics of this data set also. Okay. Next, we can plot the data set also by using the simple plot command. Plot, and then in parentheses air passengers. So you can apply these techniques on any dataset. Either if you have any dataset and you want to do practice. In last class also I told you there is a website kaggle.com. So on that a lot of data sets are available. If you want any bank loan data or any production data, just in the search engine write that and you will get the dataset. Save it as a CSV file. Then import it in R by using the command read.csv and giving the path, and you can load it. Then you can perform analysis on that. So do this in your practice, get the data set on from Kaggle and perform your analysis. Okay, so plot air passengers when I have done. So here at the right hand side down, you can see the graph is there. You got it?
Got it.
Okay. So you can change the color also. Now I have given plot in parentheses air passengers. Then comma call is equal to blue. So its graph is blue. Then call is equal to red. So the graph is red now. Okay. Green is there. And main heading, you have to use main is equal to and then inverted commas air passengers. Okay. Clear?
Clear till now.
Okay. But you have to do your practice only. Then you will learn.
Sir, how this
Then we can,
all the analysis we have done, we can present it, or we can go to some either Excel file or PPT.
no, once you have done, you just need to import the data first, because this is R is best for importing the big data. So if any data which you cannot analyze in Excel, or you want to get the data from the website, that is a big data, huge data, and you want to apply the analysis or plots at a granular level for data visualization, R is best, and for statistical functions, it has more better functions than Excel. So then you have to first import the data, perform the analysis, apply the statistical functions, plot the data, and then save it. If you press a Control S, it will show you that where to you want to save it, location, and then .r data file will be saved with the extension .r data. Okay.
But how can we present it to someone who is seniors?
Present you can
How
do
can I
in a
show my
number of
analysis
ways.
to the?
Yeah, in Power BI also, I will share with you people one PPT which will show you the step by is all the steps that how to integrate R with Power BI.
Then
So
we
you
can
can,
form the presentation over there.
yeah, you can see in Power BI at the visualization pane there is R script and Python script also there. So once
Yes, sir.
you see the R script, you can, and I will share with you. You just follow the steps, and inshallah you'll do it. So just open there, and then you can present. Okay.
Okay.
Now I want to convert this data set into time series data by using the TS function, which we have learned before. So TS data, I can
In
define a
this
variable.
TS, you have seen the class which is TS data. This data
Yes.
is TS, already a TS. So why we need to convert it to TS?
No, I am giving the frequency. Let's say I want to change it in different frequency, like monthly or like this, or I want to decompose it. So that's why I am using the TS function to decompose. Okay. The data is already in a time period. So it is time stamp data. But I want to change the frequency. So I have to use the TS function. Okay. TS data, air passengers. And then frequency is equal to, let's say I'm giving frequency is equal to, what was the frequency? Was monthly or what?
Yearly, we should put
Well,
one.
but I want to give monthly, so I'm giving 12. So TS data is there. And we can put 4 also for quarterly data. Okay. If we give 4, it will convert the data into quarters. You can see down the data. It is in quarters.
So
Okay. Or if I put 12, so it will.
have we seen what is this data all about?
Which data?
This air passengers. Have we seen it?
It is in the base R. It is available in the base R,
Okay.
not in any package. So now to decompose the data. So I have to give another variable, that is d data, just to decompose it in the various components. So I have to give the assignment operator, d data assignment operator, and then give the function decompose. There is a function decompose. It's classical seasonal decomposition by moving averages. It decomposes the time series into seasonal, trend, and irregular components using moving averages. And it deals with additive or multiplicative seasonal component. So you must know that in Excel also there are so many functions of smoothing and moving averages and all this. So I will share with you that work also, that how to do in Excel. Decompose, then in bracket whatever the time series data we have defined, TS data, and then comma. There are two types of decomposition, additive and multiplicative. So let's say we are giving multiplicative, and then control enter. So it has given the D data. If I give D data, it will give me the class decompose.ts. So now we can plot this decomposed also plot by giving the generic uh, command plot and then D dot data. So this you can see at the right hand side plot is the decomposition of multiplicative time series. So it has decomposed the random, seasonal, and observed values. Okay. then we can see in the different graphs also this, because it in this one graph it has decomposed all the random, seasonal, and observed values. Let's say we want to see the different components individually. So how to make that? We can plot that. We can perform the trend analysis by using the plot function separately. Let's say plot and d data dollar trend, d data dollar trend. So just when I type d data dollars, so it is showing me seasonal, trend, random, all separately. So let's say I want to plot the trend. So it will show me the graph, this one. Let's say it's a trend analysis. So I can write also comma main is equal to inverted commas trend analysis. Trend analysis. So control enter. So it has given the main heading trend analysis. Okay. Then I want to see the seasonal effect, the component seasonal. So I have to give the generic command plot, and then the data set name d data, and the particular column, for particular column I have to give dollar sign, and then I don't want trend, I want seasonal. So I have to give seasonal and control enter. So now it has given me the seasonal effect before the trend, now the seasonal effect. And let's say I want to see the random effect. So I have to give the command plot, the data set d data dollar. Now I can select the random effect, random, control enter. So it is showing me the randomness in the data. So this is how we can see the we can perform trend analysis, seasonal analysis, and we can see the randomness in the data. I will share with you the today's PPT lesson notes, so you can go through these all concepts again. Okay, till now clear?
Yes,
We
clear.
can
Yes. Yes.
we can draw a ab line also. If we plot air passengers, plot, and then parenthesis. It has a lot of things, but you should do in your practice one by one. You should apply various codes and various approaches. Then you will learn.
Shraddha, how
We have
will
the
get the future forecast?
in R or Power BI.
In R. Now we have a time series. We have done the decomposition. We analyzed it, but the
Hmm.
main feature of time series is what we want to have a prediction about the future. So how to do that prediction?
Once you load the forecast package, you can do in that also. You can use the forecast command. Okay. Just
Can we
load the
perform this data?
forecast.
Yeah.
Yeah, I will share with you the lesson notes in which the forecast time series data is there. So you just type the codes, and then you can apply that. Now I am just completing this box plot also of this. How to do the box plot? And I will share with you a very good book from R Matrix, that is basics of R for finance. So you can do your practice from there also. A lot of exercises are there and illustrations are there. Okay. How to do the box plot? You have to give the command box plot, and in parentheses air passengers, the data set name, and then you have to give the variables, or you can use this function, the dependency. Cycle, and then in parentheses air passengers. then comma, X lab and Y lab you can also give. Date. And Y lab is equal to passenger numbers. And main heading also you can give. So it has plotted the box plot. And main heading you will give main is equal to, and whatever the heading air, air passenger, so it will give you the air passenger data. Okay. Well, the battery is also going to finish. You got the box plot? Hello?
Shazad, working.
It is working?
Means I'm performing. Just give me a minute.
Yeah.
It hasn't shown the heading from the main. And top type main is equal to air passengers, but it doesn't display.
Okay. Now you have, I think you have loaded the forecast library because I have loaded it up. Library forecast. So I have loaded it. Okay. Can you load the library forecast?
It's only loaded, but doing work on.
Already loaded? Okay.
Yeah,
So then you can see there is a ARIMA function also. For help, you can write help and or you can write question mark and then write ARIMA, ARIMA. ARIMA modeling of time series. ARIMA stands for autoregressive integrated moving average. This is a one of the time series model. ARIMA. Autoregressive integrated moving average model. Okay. Once you type here, it will give you the help at the right hand side. Okay. And in my these notes which I will share with you, there is a detail about the ARIMA model also. And let me discuss the ARIMA model first, then I will do the code for ARIMA model. Okay. You have any idea about ARIMA model? ARIMA or ARMA model?
no, sir.
No idea? Okay, let me discuss first the ARMA model. Actually, it's a model of time series analysis, and it has two components. Let's say yeah, that's why we called it ARMA or ARIMA. ARMA means auto-regressive moving average. So it has two components. First is the AR component, that is the auto-regressive, and the second is the MA component, that is the moving average. So when we combined it, integrated, it becomes ARIMA, auto-regressive integrated moving average. So in which there is an autoregressive component and moving average component also. So what is the autoregressive process? Autoregressive is that, let's say you have two values, and autoregressive models are most widely used in time series model in finance. Let's say the you have two time periods. So first is the let's say the time period is T, the current time period, and the last time period, that was, you can say, T minus 1. Okay. So if you are comparing this period with the last period, so you can say this is the AR process, autoregressive process, in which the values of the current period are dependent on the previous period. In forecast also we are doing this. Let's say we are forecasting the sales figure based on the previous figures. Let's say we are saying in the next period, the sales will be 10% of the previous year. Okay. We are doing like this in forecast. Correct? Hello?
Yes.
So this way, we are doing this, the AR process. For example, we are comparing, we are finding out the GDP of a country. We are saying the current GDP of a country, let's say YT is dependent on the last year's GDP, YT minus one. So in this way, this is the auto regressive, or we are just forecasting the sales figure. So we are saying the this current period or next period sales will be 10% of the previous period. So in which we are looking the auto regressive process in which the current period depends on the past period. And the autoregressive is a model, AR and MA. In the time series modeling, these are used. The first order autoregressive is called AR in parenthesis 1 or 2 or 3 like this. So AR1 process is the form of a variable regressed against its own lagged prior year values. 1 comma 2 means for current period with the last two lag periods you are regressing. Regressing means yani once we are doing regression, so regression means one variable is regressed with the other. Regress means is this an independent variable? It is depends on the other variable, that is independent variable. So it means it is regressed with the other variable. So it means that if one variable is regressed against its own prior period, that is called the AR process. But on the other hand, in the moving average, the MA process is a linear regression of the current values of the time series against both the current and previous noises or error terms or random shocks. So in AR, we are just looking the current period with the which are regressed with the prior period. Okay, in AR process. But in moving average, not only this, like the AR, like the current period with the prior period, we are looking the random errors also. So MAs are always covariance stationary means they are having the stationarity effect, and the first order moving average is MA1, yani with the first period, or MA2 like this. So there is an equation also, but it will be very complicated. So I'm not going into detail. So just I am telling you that in ARMA, that is autoregressive. ARIMA, we are also called ARMA and ARIMA also. So what is ARIMA? Autoregressive integrated moving average, in which these two autoregress and moving average, both components are integrated. So that's why it's called ARIMA, autoregressive integrated moving model. What is this model? It says both the two components, and it is possible for time series to show both the signs of AR process. Yani the values are current values are regress with the past values or the prior year period values, and the MA process. Yani not only current past, also with the randomness or shocks or errors. So in that way, this type of relations we use the ARIMA model, autoregressive moving average model. And for example, like stock prices, these stock prices might show evidence of being influenced by both unobserved shocks, any the randomness or the shocks or any trends जिसकी वजह से affect होगा एकदम से. So due to these random errors or shocks, the prices are fluctuating sometimes, and their own lagged behavior, that is the autoregressive component, that the change is in the current period is regress with the changes due to the past period or prior period effect. So that is the AR effect. So there are two type of effects. One is the AR effect, autoregressive, and the other is the moving effect, moving average effect. So this relationship is called an autoregressive moving average ARMA process and is expressed by the equation YT is equal to D plus 5 YT minus 1 plus ET. So in this, D is the intercept. Like if you remember the linear regression, Y is equal to A plus BX, in which Y is the dependent variable and A is the intercept, and B is the coefficient and X is the independent variable. So in the same way here, D is the Y-intercept and YT minus 1 is the Y is your any variable, let's say sales or advertisement or anything. So let's say our data is main variable is sales variable, and it is an independent variable. Sorry, y is dependent variable and your independent variable other variable. So E is the error term. In that way, you can see that how you can calculate the ARMA. But here in R, we have some function so we'll use. So there are assumptions of ARMA model that data should be, first assumption is data should be stationary. And what is the meaning of stationary? By stationary, it means that the properties of series does not depend on time. Yani mean and variance should be constant, which we have seen in the start. And a white noise series, white noise, leave it, white noise is like error. Data should be univariate. ARIMA works on a single variable. So for ARMA, there should be two assumptions. One is the data should be stationary. Second, data should be univariate. ARMA cannot be applied on bivariate or multivariate analysis. Okay, now ARIMA model has three parameters. That is P, D, and Q. What is P? Number of autoregressive terms, AR terms. D, how many non-seasonal differences are needed to achieve stationarity, and Q, number of lagged forecast error in the prediction equation, MA. So AR component, the current period depends on the prior period or regress with the prior period, and MA component, not only this the randomness or shock is also there. So both the ARMA is the combination of the integrated model of autoregressive and moving average. So in which there are three parameters P, D, and Q. And then we can illustrate this ARMA model that this model predict future values based on the past values. And ARIMA makes use of lagged moving averages to smooth time series data. Is a smoothing technique, and they are widely used in technical analysis to forecast future prices. And just an example, let's say we are considering sales of an item. That is in the equation I discussed with you. Let's say YT is the sales, Y is the variable, and T is for time. So YT, and a random shock of advertising. So this is called a random shock or white noise because once advertisement is increased, so it just have an effect on the sales. So we could attempt to forecast the sales for an item as a function of the previous period sales. So this is the AR component in which we are just finding out or forecasting the sales as a function of the previous period sales, YT minus 1. Let's say this period is YT, so last period sales are YT minus 1. So in the current level of advertising, which we are just putting as a parameter, that if we spend this much amount on advertising, so what will be the effect on the sales? So this is the current level of advertising, that is ET, that is the random error or shock. And the one period lagged of advertising, ET minus 1. And in the last period, how much was the advertising? So we can say that this period advertising is ET and last period advertising was ET minus 1. And this will show us that the current period could be affected by both the past sales, that is the AR component, and by random shocks or this advertising effect, that is the moving average MA component. So in that case, in our this example is this advertisement is the random shock which affects the sales, that is the MA component. And the sales itself depends on the past period sales also, that is the AR component. So that is this ARMA or ARIMA is autoregressive integrated moving average. It is having both the two components, AR and MA. Okay. Another possible random shock for sales could be the seasonal effects of weather conditions, because if the company is manufacturing the ice cream, so in the winter, definitely there is a random shock for sales because due to the seasonal effect or the weather conditions, the sale will be declined. So the random shocks are like advertisement or marketing. When you increase the spending on advertisement, sales will be increased. Or when you have the weather conditions or the seasonal effect, then the sales will be also be affected by the random or seasonal effect also. So this example we just apply on the air passenger data set, that is the data set in base R. जिस पे भी हमने apply किया था बाकी functions. So we will predict the airline tickets for using the ARIMA model, and it will show us the time series components like trend, seasonality, and random behavior of data. So let's say apply the, till now we have done the decomposition by giving the random effect, trend, and the seasonal effect. Now I'm going to apply the ARIMA. So I can use the code, or I can define a variable, let's say my model or a model simply. So because if I type model, maybe there is a model already functions are there. So better to use my model and assignment operator. There is a function auto.arima. If you type auto, there is a autocomplete feature. So in R Studio, so it is showing auto.arima and others also. So select auto.arima. Are you following along with me?
Yes, sir, trying to.
Okay. Actually ये थोड़ा सा एडवांस टॉपिक है, बट टाइम सीरीज मॉडल्स में अरीमा होता है, so that's why I'm doing auto.arima and then air passengers dataset. So dataset name, that is air passengers, and then control enter. So you can see the variable my model as assigned in the environment. Just type my model, then click on that and control enter. So you can see in the console, it has given ARIMA 211. So this 211 are the parameters of the ARIMA model, that is the PDQ. Okay. We have just discussed before what are the PDQ. Do you remember? P for number of autoregressive terms. यानी आप वन पीरियड लैग से उसको दिस पीरियड को कंपेयर कर रहे हैं, या टू पीरियड लैग से. लैग पीरियड मींस अभी 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 आप अगर थर्ड पीरियड में है तो आपके जो गोइंग फ्रॉम थर्ड पीरियड टू सेकंड पीरियड इज द वन पीरियड लैग. अगर अभी आप फिफ्थ पीरियड पे हैं तो गोइंग फ्रॉम फिफ्थ पीरियड टू फोर्थ पीरियड वन पीरियड लैग. फोर्थ पीरियड टू थर्ड पीरियड टू पीरियड लैग. थर्ड पीरियड टू सेकंड पीरियड थर्ड थ्री पीरियड लैग. So it's a lagging of periods. So P is the number of autoregressive terms. D, how many non-seasonal differences are needed to achieve stationarity, and Q, number of lagged terms in the prediction equation. So P, D, Q are the parameters of the ARMA model. So once I have applied this, it is shown that down series is air passengers, ARIMA 211, that is the PDQ, and it has shown the coefficients. You have the AR1 and AR2, any autoregressive one, first term, and autoregressive second term, and MA1 is the moving average one. So it is going giving the coefficients, and this is the ARIMA model. We can apply the box junk test also. It will show us the model is perfect or not. So let's say box dot test. What is a box dot test? It's compute the box pairs or box junk test statistic for examining the null hypothesis. So it's just actually checking the, it's a diagnostic, just checking the model is accurate or not, to check the accuracy of the model. So box dot test, in which you have to write the model name, my model, and then you have to give dollar and residuals, comma, lag period. You have to define lag is equal to, let's say 4 or 5 period lag periods are there, and type is equal to, you have to give the type also. Type is equal to, here you have to type the junk box, and box in inverted commas, and control enter. So it has shown us the box junk test, and the data is my model dollar residuals. X squared is equal to 2.9244. DF is the degrees of freedom, is equal to 5. Means if there are, if let's say 6 terms are there, so degrees of freedom is just n minus 1. So 6 minus 1 is 5. And p value is equal to 0.7116. This is a p value is probability value. It is showing the significance. So what we have seen in that, we can see that by creating a time series forecasting model using the ARIMA model, autoregressive moving average model, to predict, in order to predict the sales of this airline dataset. So And this box jump test, why we are using? Just to calculate or find out the x squared value and p value. And this p value of 0.716, what it is showing? It is showing us that our model is accurate, and we can conclude that ARIMA model with parameters 2, 1, 1 adequately fit the data. Because if the p value is too much high, like 1.2, 2 point something, so it means the probability value is high. It means it's a question of for the accuracy, but the p value should be low. So we can then conclude that the model is accurate. So now what you have to do is, these are the some of the concepts we have discussed, and some of the codings we have applied on the different like this data set, and before also on some vectors. Now you have to use any data, any from Kaggle website or from any other website. If you are doing production data, then you can apply on that regression and then time series and all these concepts you have apply on that data set. Or if you are concerned with the uh, banks or any such type financial institutions, so you can get the bank loan data or credit risk data from the Kaggle or from other websites. And there is a GitHub also. From there you can see the projects also. So you just need to import the data set by using the or file read.csv file. You can save the file from that website, then import the data, then do the model estimation, test for stationary, perform the decomposition, and then apply the ARIMA model by using the auto.arima function. So there are the three steps you'll see in the lecture notes also. First is the importing the data by using the read.csv command, then converting it into data frame, then converting to time series. If it is not in the proper frequency, then estimate the model estimation, then test for stationarity, and then apply the ARIMA model. So till now, I have completed the time series data today, and I will share with you people today's lecture notes, and tomorrow I will share with you that PPT also covering the Power BI area, some of the features of Power BI, and then how to integrate R with Power BI. Step by step instructions are there, so you can do that also. And this are the courses designed basically to give you the introduction of R, statistical functions in R, then financial market analysis, and then the fourth time series analysis. R is very huge, so you just apply the R functions or concepts or whatever you have done in your area of work, so that you can see that how you can apply R in your area or your work, how to do the statistical functions, how to get or import the data in R, how to perform the statistical functions, how to analyze it, how to do data visualization, how to do the time series modeling. So this area you have to confine yourself in this. Otherwise, it's very huge area, and nobody can learn each and everything. So just try to focus on this area, and then apply this to your practical whatever you are doing, the R concepts. And I will try to share the material I have so that you can do your practice, specifically related to application of R in finance. Definitely, you have to go for that. Okay. Any questions?
Thanks a lot, Shazad.
Okay, so inshallah we'll be in touch, and if you have any questions, you can just discuss in the group. So then talk
For
to you
sure, we
later.
will be having many questions. Actually, we didn't got much time to do some practice. While doing practice, we'll have definitely questions, and we need your help going forward
I
as
will
well. Thank
I
you.
will share with you the basic R for finance also. So it has a lot of examples are there. So you just need to use that examples or illustrations and do on your own. So if anything you want to ask, you can ask. But if you ask each and everything is small, so nobody can help you. So just follow the commands in that. I will share with you the basic R for finance. So it is very good. So you can do your learning, and then definitely we are here for Power BI and R also. So you can discuss with us. Okay. Thank
Sir,
you.
you have also mentioned that you will be launching a new course, credit risk modeling. So what would be this related to finance guys?
What? Which thing?
This credit risk modeling.
It's credit risk modeling. I have mentioned in that because it's not covered in this course. But I am just planning to conduct a course on credit risk modeling in which I will discuss the IFRS 9 expected credit loss ECL model, and then ECL components, PD, LGD, and EAD. Probability of default modeling is there. So R, we can use R also for PD modeling. So I am working on that. So inshallah, in future maybe I will launch. Then I will just discuss the IFRS 9 area, and then what are the bank's Basel requirements, and then how to do this credit risk modeling in R. So this is my planning. Any course will be there, inshallah.
So,
Okay,
so
okay,
thank you for it's a great
thank
learning
you.
experience. Thank you. It's
Inshallah.
this course is very large. Though we didn't found much time to practice, but I am sure that after practicing we will be having something.
Yeah,
Thank you.
inshallah. You just need to apply this in your
Yeah,
practice,
yeah,
so you
yeah.
learn more. Just
Basically, it
completing
covers
a
a lot more statistics which we are not in practice.
yeah. So I have discussed a lot. So just to follow
Yes, sir.
these
Yes.
and
I will.
see
Sure.
how to apply in R, then you will learn only.
So,
Okay,
thank
thank
you,
you.
sir. Thank you. Thank you. Allah
Walaikum.
Hafiz.